To the video for lesson 3-7. Hopefully you've done the prep skills. You'll notice we're working with equations, which is going to involve writing expressions as you see there. You need to remember your slope and your y-intercept, and once you have an equation, you can plug a number into it or an inequality and solve that equation or inequality. So hopefully you've looked through those, and hopefully you've read the introduction here. Alcohol is an interesting thing. It's the only, one of the few chemicals that your body gets rid of at a linear rate, and we're going to make use of that. So kind of interesting. From that standpoint. If you haven't done the prep skills yet or read through this, do that first and then restart the video and we'll move on to the classwork. Okay, try number one. First of all, read this. Try number one. Once you've done that, come back to the video. So we're talking about a year-end pizza party here. So you've got pizzas for $9 each, and there's $175 in the budget. How many pizzas can you get and stay under budget? That's the key here. And as before, we're going to look at this from several different perspectives. One will be the one you most likely use, and there's nothing wrong with that. But use that understanding to develop an understanding of the other approaches, because there are problems where the other approaches will work better. So we're learning different things based on an initial understanding. So use a numerical calculation, include all details, and don't forget to write the number of pizzas you can buy. So most of us are going to say, well, I need to see how many times I can take $9 out of 75. Sorry, 175. So I'm going to take 175 divided by 9. And I'm immediately going to go to the calculator for that one. So 175 divided by 9 gives me 19.44. And I'm going to say that equals 19.44 pizzas. But really, I can buy 19 pizzas. So question 2, hopefully we have this understanding. Question 2 wants you to look at that from the standpoint of an equation. So restart the video after you've done question 2. Okay, question 2. Write an equation that represents the total cost, C, of ordering P pizzas. So C equals, what does this tell you about the cost of pizzas? So first of all, if we know how many we're going to order, if we order P pizzas, we're going to pay $9 for each of those. We will multiply 9 times P. If you're still struggling with writing that, I think everybody knew you were going to multiply 9 times the number of pizzas. That's all we're asking you to do here, to say 9 times P, where P is the number of pizzas. Okay. What does this tell you about how the cost varies when you change the number of pizzas ordered? For every pizza you order, the cost goes up $9. You order one more pizza, you pay $9 more. That's what the equation tells us. You probably The book is hoping you will say that it varies directly, if you remember lesson 3-6. It's a direct proportion, or it varies proportionally. So, anyway, try number 3 and come back to the video once you have an answer. Okay. Question 3, you buy 0 pizzas, you pay $0. Getting ahead of myself. 5 pizzas, 5 times 9 is 45. 10 pizzas, 10 times 9 is 90. And I should be putting dollar signs here. And I should be putting 2 decimal places. But we're in a hurry. 135, 180, 225, and 270. Question 4 looks like it's going to ask you to graph that data. So go ahead and do that, and then come back to the video. Okay. So for my graph, I have number of pizzas on the horizontal axis. I have cost on the vertical axis. The first point I have to graph is 0 pizzas, $0. Now I have to think about my situation here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10, and I know so far, well, according to my table, I have to go up to 30 pizzas. So I can say I could go by threes. I could go 3 for every line. That would, I would end up at 30. But my table goes by 5, so I'm going to choose 5 for each line, which means 2 lines will be 10, 20, and 30, 40. Okay. And my cost, if I remember right, my cost went up to 270. And for my purposes here, I want to get a little more accurate, so I'm going to say I need to go up to 300. And I've got 1, 2, 3, 4, 6, 7, 8, 9, 10 lines again. So every one is going to be 30. So $30 for the first line, $60 for the second line, 90, 120, 150, 180, 210, 240, 270, and then 300. Okay. So it's not as easy to work with as the number of pizzas, but gives me a little bit better use of my graph. So at any rate, $0, 0 pizzas, 5 pizzas, $45. That's going to be halfway between 30 and 60. 10 pizzas was $90. And since every line is going by 30, that's halfway between 60 and 120. 15 pizzas, let's see, 20 pizzas was 180. 15 pizzas was 90 plus 45, or 135. 135 is 15 more than 120. It's 15 less than 150. So it's halfway in between those two lines. And then 30 pizzas we knew was 270. And 25 pizzas would be 45 less than that, which is going to be 15 less than 240. Okay. So make sure you label the scale on each axis. Use your graph to estimate the number of pizzas that can be bought for 175. Try to ignore the answer you found in question 1. Use only the graph. So I've got my line here, and I'm amazed at how straight I drew that. We're now going to use our graph. So $175. So I go over here to find $175. That's almost 180. And I'm having trouble drawing a straight line again. So I can buy a little bit less than 20. It looks like about 18 or 19, but it's hard to tell off the graph. Using only the graph, I'm going to say it's about 18, although I remember it is 19. But that illustrates that graphs are good for visualizing things. And you can use them mathematically to some degree of accuracy. Okay? So anyway, try question 5 and restart the video once you have done question 5. Okay, question 5. Since we want to spend at most $175, this is a good place to use an inequality. Write an inequality that can be used to find the number of pizzas you can buy for at most $175. Then solve that inequality and use the result to decide on the number of pizzas you can buy. So if you remember back, we had the equation C equals 9p. We're going to use that equation to write our inequality. So instead of our C, though, instead of C, I'm going to go ahead and put in the value. The cost is at most $175, which means my actual price has to be less than $175, or more appropriately, $175 has to be greater than my actual cost. My actual cost is 9 times the number of pizzas. So then solve that inequality, use the result to decide on the number of pizzas you can buy. When we solved inequalities, we did the same thing as when we solved equations. So 175 divided by 9. And if you'll remember, when we thought the problem through at the beginning, what we did was take 175 divided by 9. This is just a fancy way to use our variable p. We can now say p has to be less than, I'm going to change that to less than or equal to, because 9p could equal 175. We know from what we've done that it doesn't, but theoretically, if it did, we'd be okay. So 9 divided by 75 ended up being 19.44. And now I can say $19.44 has to be greater than or equal to P. It helps to think of it, though, in terms of the price, P is the number of pizzas. Helps to think of it in terms of the number of pizzas. So I'm going to say P has to be less than or equal to, that's not dollars, it's the number of pizzas. So 19.44 has to be greater than or equal to P, the number of pizzas, or P, the number of pizzas, has to be less than 19.44. And that's what we chose to do when we solved the equation originally. Question 6 goes on talking about the equation and the graph that we did, the table. Once you've answered question 6, come back to the video. Okay, number 6, what's the slope of the line you drew in question 4? What does it represent? Well, slope of the line, we always do y2 minus y1 divided by x2 minus x1. Some of you may have answered this without doing that, and that's actually good. Don't be upset about that. I'm hoping we get to the point where you can answer this without doing the actual calculations. Although you want to remember how to do the calculations, but your understanding should allow you to avoid the calculations at this point. I'm going to take 20 pizzas and 10 pizzas. So y is the number of pizzas. Y is the price. X is the number of pizzas. So I'm going to have 180 minus 90 divided by 20 minus 10. And you can take any 2 points that you want. We've found before that doesn't matter. 90 divided by 10. I'm going to add my units now. $90 divided by 10 pizzas. So my slope is $9 per pizza. And hopefully you all realize we could have gotten that straight from the story. At this point, I want you to be able to do the calculation, but I also want you to recognize that's the number that came right in the story. Okay. Question 7, what's the y-intercept of the line? What does it represent? Once you have answered question 7, restart the video and we will discuss it. All right, question 7, we go back to our graph. Our y-intercept was right down here. The y-intercept is 0. And we can get that looking at our table also. Once again, we can actually think about the story. Story tells us there is no y-intercept. We just pay for the pizzas. So our y-intercept equals 0. What does it represent? In terms of the story, the y-intercept represents the cost for 0 pizzas. A lot of people will say the y-intercept represents where x is 0, or it represents where the line crosses the y-axis. Mathematically, those are correct. When we say what does it represent, though, we're talking about the what does it represent in the context of the problem. The context means the story. So yeah, it's where the line crosses the y-axis. It's where the cost for 0 pizzas. It's where it's the y value when x equals 0. Those are all valid things. Okay. Looks like we have a did you get it coming up. If you don't get the did you get it, send me an email and we can find a way to discuss it. All right, so nice job so far. They're changing it up now. Okay. We're going to add a delivery charge. So see if you can answer question 8 now that there's a delivery charge. Once you've done question 8, restart the video. Okay. Question 8, write an equation that describes the cost C of buying P pizzas with the delivery charge included. So we've still got C, and we're still paying $9 per pizza. But now they're going to add a delivery charge. And hopefully you see. So go on to question 9. Once you've answered question 9, come back to the video. Question 9. Kind of a little bit strange. What's the cost of ordering 0 pizzas? Technically, if you don't have them deliver them, you don't have to pay the $10. But in terms of the math, it's interesting to think about. You know, you pay $10 just to have them come out and say hi. Then if you buy 5 pizzas, you have them deliver 5 pizzas, you pay $45 for the pizzas, you pay $10 for the delivery charge, $90 for the pizzas plus $10 for the delivery charge. 90 plus 45 is 135 for the pizzas, 145 with the delivery charge. So 180 for the pizzas. If you order 20 pizzas, $180 plus $10, 190. And you'll notice every time, doesn't matter how many pizzas we order, they only charge $10 for the delivery. Okay. So 25 pizzas, that's $45 more, 225 plus 10 for the delivery, 235, and then 30 pizzas was 270. With the delivery charge, it's going to be 280. Looks like question 10 wants you to graph this. Restart the video once you've done that. Okay. So I'm going to use the same scales as I did before. So 5 pizzas per line would get me up to 50 pizzas. And going up to $300 will work. Even with the delivery charge, I'm still at 280. So if I go up by 30 for every line, 60 for every 2 lines, 120, 180, 240, and then 300 for the top line. And I have 0 at my origin. So now if I graph my pizzas, 0 pizzas is going to be here at $10, which is a third of 30. So I go a third of the way to the first line. Then 55 for 5 pizzas, just slightly below 60. And $100 for 10 pizzas, 90 plus 10. So the between 60 and 120 would be 90. $100 is going to be a third of the way between 90 and 120. Okay. 15 pizzas, 145. So 120, 150. 145 is just below 150. 20 pizzas was 190, which is just a little bit above 180. 25 pizzas, let's see, 30 pizzas was 280. So 240, 270. So I'm a little bit above 270. A third of the way between 270 and 300. And so 230 for 15 pizzas. 235. So really I'm just a hair below 240. 40. If I draw my straight line, I end up with a graph of the number of pizzas versus the cost with the delivery charge. They want us now to estimate the solution to the problem. So the problem is, how many pizzas can we order? We've still got $175. So I'm going to approach that the same way. I've got my 175, which is just below 180. And this time it's still about 18. I'm going to say 18. Well, you'll notice my line looks like it's kind of veered down a little bit. I didn't draw an actual straight line, so it's hard to get an accurate estimate, but we know we're kind of close to 18. So go on to question 11. I have a feeling question 11 is going to have you calculate this somehow. Restart the video once you're done with question 11. Question 11 says, write and solve an inequality that can be used to find the number of pizzas you can buy with the delivery charge added. So we've got an equation. C equals 9p plus 10. And that's we call that, we use an equation there because we're actually calculating C. If we know P, we can find the exact value for C, but we want to, given C, knowing that we have a limit, C has to be less than 175, or more importantly, 9p plus 10 has to be less than or equal to 175. So when I calculate C using 9p plus 10, that value has to be less than and I said it one way, I wrote it the other way. The value that we calculate has to be less than or equal to 175. The actual charge, the actual cost of the pizzas has to be less than 175, or we can also say 175 has to be greater than the actual value. So to solve it, we now know the pizzas have to cost less than 165. If you were just thinking this problem through, you'd say, well, if I've got a $10 delivery charge, I've got $165 to spend on pizzas. So my cost of pizzas has to be less than 165. And if you're just thinking the problem through now, you're going to say, well, I'm going to take my 165 divided by 9. And when you're solving an equation, all you really do is, or in this case, solving an inequality, all you really do is divide the other side by 9. That gives you a way to write your P out here. P is less than or equal to 165 divided by 9, which is 18.33. So 18.33 has to be greater than the number of pizzas, or better way to say it in terms of this problem, the number of pizzas has to be less than 18.33. Which, in terms of the problem, means we have to get 18 pizzas. Okay? And that's kind of what question 12 is talking about. So restart the video once you've done question 12. In this situation, would you say the cost of ordering pizzas varies directly with the number of pizzas? Explain. Direct variation means you double one, you double the number of pizzas, you double the cost. We double the number of pizzas, we go from 10 pizzas to 20 pizzas. We're still doubling the cost of the pizza, but we're not doubling the total cost. 10 pizzas is $90, 20 pizzas is $180. So we double that cost, but we don't double the cost of the total because we just add $9 each time. We add we add $10 for the delivery charge. We add $10 to $90, we get $100. We add $10 to $180, we get $190. $190 is not twice $100. So by adding 10 each time, we no longer have direct variation. Go on to question 13. Okay. Question 13, hopefully you know how to do the formula. You've done it a lot. You can go back to the table and do that if you want. But really, the slope of the line, when we calculate cost in terms of pizzas, the slope of the line is the cost of one more pizza. If we want to order one more pizza, we have to pay $9 more. The slope of the line is still $9 per pizza. Restart the video once you've done question 14. Question 14, y-intercept. Y-intercept is where the graph crosses the y-axis. It's also the value of y, in this case the cost, if you get 0 pizzas. So if you call up the pizza place and ask them to come out and say hi and not bring any pizzas, they're going to charge you $10 just to come say hi. So the y-intercept is actually $10. What does it represent? This is where it gets kind of interesting. In the context of the problem, the best way to say it is it represents the cost of coming out to the party. It's the cost of bringing the pizzas to the party. It's not really the cost if you order 0 pizzas. Technically, if you order 0 pizzas, you wouldn't have to pay anything. But it's the cost of driving out. So if they drove out and brought no pizzas, then you would have to pay $10. Really wouldn't happen. But when you're talking about what does it represent, it represents the cost of bringing the pizzas. It represents the constant cost that is not dependent on the number of pizzas. When we look at the graph, we look at the table, it is the value, it is the cost mathematically that we calculated for 0 pizzas. But in the story, in the context of the story, that's not really what it is. So it's the cost of bringing the pizzas out is the best way to say that. Looks like we have another did you get it? If you don't get it and you can't figure out why, send me an email. Question 15. Okay, they want you to think about how to say some different things, which is a good way to develop your understanding. So do some good thinking about what you're going to put in those spaces, and then restart the video once you've done that. Okay. Now here's the key idea. Look back at your answer to question 8, 13, and 14. The slope was $9 per pizza. And I've got to go see what question 8 was. So question 8 is where we had started with the $10 $10 delivery charge. So in all of those questions, the y-intercept was $10. And the equation was C equals 9p plus 10. We wrote some different inequalities using that equation, but that was our equation. This fits the form of many of the linear models we've studied previously, where the equation was was of this form: y equals. So we usually use y for the number we're calculating. Starting value of the quantity. So in this case, what the value is when x is 0. Constant rate of change. For every additional x, we get another, in this case, $9. That remains constant no matter how many pizzas you order. So, and then they mention that starting value means output associated with input 0. So if we make x 0, the y we get is the starting value. In algebra, we call this the slope-intercept form of the line, because the two constants in the equation are the slope and the y-intercept. That helps us because if we're writing an equation, we can usually find the slope from the context of the problem. We can usually find the y-intercept from the context of the problem. Okay. There'll be some situations later where we have to calculate the slope and the y-intercept, but we will deal with that when we get to it. So if we give you an equation, you can tell us the slope. The slope is the number next to the x. You can tell us the y-intercept. That's the number by itself. Or if we give you a story that has a y-intercept and a slope, you can write the equation of the line. Okay. And that's what they're saying here in the purple area. When a line has a slope m, and the second coordinate of its y-intercept is the number b, then the equation of the line is y equals mx plus b. So let's go on to question 16. Restart the video once you've answered question 16. A small business had just 12 employees when they opened their doors. Okay. Open their doors, that indicates the start of the business, but have been adding employees at a rate of 4 per month since then. So 4 per month means every month there are 4 more employees. So that gives us an idea that we know what we start with. We know how much it changes every month. So we now know that months is going to be the independent variable, or what we'd normally call the x. So write a linear equation that describes the number of employees in terms of the number of months after the company was founded. So I know I need employees m equal months. So I'm going to start off. I like to start off with the, well, I'll start off, we know we're going to calculate the number of employees. So I'll say E equals. Then I like to think about the months first. So if I know how many months, at 10 months there would be 40 employees, because I would multiply 4 times 10. So I'm going to multiply 4 times the number of months. We say that in math class by writing 4m. 4m means we're going to multiply 4 times m. And the first 12 employees haven't quit, so we still have the 12 that we started with. Answer question 17 and restart the video once you're done. Question 17, what are the slope and y-intercept? Actually, in this case, it's going to be an e-intercept, but we generally just say y-intercept, even though we don't use y. So what are the slope? Okay, slope is m. I'm sorry, slope is 4 because it's multiplied by m. And I was just about to write m equals 4. We normally use m for slope. I should have thought of that when I used m for months, but so months is not going to equal 4, except at 4 months. The slope is going to equal 4. Okay. The y-intercept, we usually write b for y-intercept, so I can say b equals 12. Okay. What do they tell us about the company? B tells us they start with 12 employees. They add 4 every month is what the slope tells us. Okay. Question 18, looks like you need to draw a graph. Restart the video once you've done that. Okay. So they don't give us any anything to go by on here. So I'm going to say don't really know how high to go. I'm just going to say we've got 10 lines. I'll go to 10 months. So first of all, months. And 1 line is 1 month, 2 lines is 2 months, 3 months, 4 months, 5 months, 6 months, 7 months, 8 months, and then the last one is 10 months. But it gets kind of awkward to put that at the end. You don't have that nice square corner, so I usually leave that one off. So now I have to think about the number of employees after 10 months. I will have 40 new employees plus the 12 we started with. We have 52. So I'm going to go, I could go by fives. I would get up to 50, but that's, I would lose that last point would be just above the graph. We don't want to see that. So I'm not going to go by fives. I'm not going to go by tens. I'm going to say 1 line is 20 employees. So 2 lines is 40. Actually, I'm sorry, if I go by fives, it won't be enough. 1 line is 10 employees, 20 employees, 30 employees, 40 employees, and then 50 employees and 60 employees. And I'll go ahead and put in the 80, even though we know we're not going to need it. I'm going to start both of the axes out at 0. Okay. So we start off at 12. 12 is a little bit more than 10. After 2 months, we're going to have 20 employees. 2 months, I add 8 employees. 2 times 4 is 8. 4 months, I'm going to have 28, slightly below 30. And 6 months, I'm going to add another 8 employees. 28 plus 8 is 36, which is just a little bit more than 35. 35 would be halfway between 30 and 40. I want to be a little bit above that. 8 months, I'm going to be at 36 plus 8, which is 44. So very close to 45, just slightly below 45. And then at 10 months is when I will have added my 40 employees. And if I look at my 44, I add 8, I get 52. That's the same as 40 plus 12. So slightly above 50. And I can draw my line through there. All right. Looks like we got another Did You Get It coming up. Kind of a summary, though, first. Um, so read through the summary. So graphing an equation in slope-intercept form, first of all, plot the y-intercept. From the story, it's what happens when you have, in this case, no pizzas or no whatever is happening in the story. Okay. For at least one other point on the graph, plot at least one other point. You can get that from the equation. You can think it through kind of the way I was doing, just based on the slope of the line. Draw a line through the points you plotted. If they don't all line up, then you must have plotted one or more of them wrong. And they're always going to be a little bit off when you plot things by hand, just because, as you saw, it's hard to be precise in the graph. That's why I drew big points. Okay, so do the Did You Get It? Use the procedure in the colored box to graph the line. So draw a graph of that line. See if it looks like the one in the back. If you have trouble with that, let me know. We can discuss it. Go on to the group work. So read this through really quickly. Restart the video once you've done that. This is what I was talking about earlier. So blood alcohol content. They actually measure the percentage of alcohol in your blood, and 0.08 is where you're considered to be under the influence. In Colorado, you're considered to be impaired if you're above 0.04. So either way, you really shouldn't be driving. But at any rate, the table kind of talks about different things that happen at different alcohol levels. And you notice at 0.04, you're starting to lose some of your reaction time. 0.1, and you're obviously drunk, really shouldn't be driving. And then it goes on up. If you're at greater than 0.5, you could actually die from having too much alcohol in your body. So different things there in the table that you can look at. And they're going to ask you about that as we go through. So go ahead and work on question 1. Once you've answered question 1, come back and check your answer. Okay. So question 1. Question 1. After being arrested for driving under the influence, a well-known starlet was found to have 3.5 times the legal limit of alcohol in her blood. What was her blood alcohol concentration? So the legal limit, which we are using in the context of this problem, we're using the 0.08. So her concentration was 3.5 times 0.08. 3 times 8 is 24, so 3 times 0.08 would be 0.24. And then half again would be 0.24 plus 0.04, or 0.28. Go on to question 2. and restart the video once you're done. So question 1, 0.28 is the percent of alcohol in the person's body, in the person's blood. Okay. Describe some of the effects of having too much alcohol. Once you've done that, come back to the video. Okay. So we need to go back to the table. She was close to 0.30, so certainly trouble walking, double vision, nausea, vomiting, but she was in danger of passing out, having tremors. So basically, these are the things that you could look for when you're describing what they might have seen. Okay. Go on to question 4 and restart the video once you're done. Okay. So question 4, first of all, we have our story. John Q. Bonehead decides it would be a good idea to drive when he shouldn't. Fortunately, he gets pulled over before anything tragic happens, and a blood alcohol content test finds a level of 0.16 at 2 a.m. Unlike most drugs, studies have shown that alcohol leaves the bloodstream at a constant rate. The table shows his blood alcohol content every hour after the arrest. Okay. So we're seeing a constant rate. We've got our table. What is the slope of the line describing John's blood alcohol content? Okay. So now I've got slope of a line. I really need my x1, y1. So this is going to be 1. This is going to be 2. And I do that so that I don't have my, like the 145. I just have 2 decimal places on each one. It's going to make the math easier. So you could also do 0 and 1 hour. Either way. So blood alcohol content is going to be my Y. Hours after 2 a.m. is going to be my X. So Y2 which means X2 has to be 2 hours, and Y1 and 0 for Y1 and X1. You'll notice, being careful about the way we did it, we end up with a negative number on the top, but you can also look at the numbers and see they're going down. As hours goes up, blood alcohol content goes down, so we know we're going to need a negative. So negative 0.13 minus 0.16. I've decided it's negative, so now I can just take 0.16 minus 0.13, and I get 0.03, but I have to divide that by 2 from my 2 minus 0, so I get 0.015. So I'm thinking of it as 0.030 divided by 2. I divide that 30 by 2 and I get 15. Okay. But it's in the hundreds and the thousands place. Okay. So What is the slope of the line describing John's blood alcohol content? What does it tell us? The best way to describe that is to start off with the x's for every hour. John is going to lose 0.015% alcohol content, or his blood alcohol content is going to go down 0.015%. Question 5. Restart the video once you've answered that. Okay. Question 5. Y-intercept's pretty straightforward because we know what the blood alcohol content is when the hours are 0. When x is 0, y equals that's a period, not a comma. There we go. The y-intercept equals 0.16. And what does it tell us? It tells us once John was taken into custody, his blood alcohol content was 0.16. And his body started metabolizing it from there. Do question 6. When you have an answer, return to the video. All right, write the equation, and hopefully now you're feeling comfortable with that. So y equals x. Okay. Didn't leave myself enough room. Okay. Negative 0.015x plus 0.16. Okay, so we found the slope. We multiply the slope times x. We add the y-intercept. Some cases our y-intercept is going to be negative. We can still say we're adding a negative y-intercept. Or you could say you're subtracting the y-intercept. But generally we add the y-intercept. Restart the video once you've done question 7. Okay, question 7. When using an equation to model a situation, it's important to recall what specific information the equation provides. Then restate your answer to question 6 in the form of a statement like this. If x represents the hours after midnight, you should be writing this out. I want you to rewrite the whole sentence because I want you to get used to writing about math. You don't want to sit there and watch me write this out. Won't look pretty on my touch screen. My stylus isn't very good. But anyway, if x represents hours after midnight, then y equals, when they say that, they're wanting us to write the equation. So negative 0.015x plus 0.16 represents the blood alcohol content. And you notice they tell us not to physically fill in the blanks. But as I say, trying to save time. So go on to question 8 and restart the video once you've done question 8. Question 8, we've learned about several features of graphing calculators that allow us to study the information provided by an equation. Substituting in values for variables, making a table, and making a graph come to mind. Using these features, discuss whether or not the equation you wrote tells the story that it's supposed to. More detail is always better. And of course, we're not using graphing calculators. You could go to Desmos.com and plug in that equation. What we're going to find So you have a starting point up here, 0.16, and then it goes down, which represents what's happening. The blood alcohol content starts at 0.16, and it goes down linearly from there. So try question 9, and restart the video once you have finished question 9. Okay. Question 9. So they're reminding us that really nothing affects your blood alcohol content except time. Okay, so what would the blood alcohol concentration be at 3:30 a.m.? Remember, he was picked up at 2 a.m., so that tells us x equals 1.5. Okay. So my blood alcohol content equals negative 0.015 times 1.5 plus 0.16. And I'm going to see if I can do that on the calculator. Negative 0.015 times, my calculator is telling me it's going to subtract. So I'm going to hit my equals, and now I'm going to clear it. Okay. So now I've got negative 0.015. Oh, it didn't clear it. Negative. Oh, it's doing negative because I am pushing the minus sign instead of the negative. It's another problem people have with calculators. So I do 0.015, then I push the plus minus button down here, and I say times 1.5 plus 0.016. And oops. Okay. 0.015 negative times 1.5 plus 0.16, not 0.016. I knew I was off because I knew my answer was going to be a lot less than since my slope is 0.015, I knew it would be a lot longer before I got to my got to a negative value for my 0.16. I knew that's a lot bigger than the slope. The y-intercept was a lot bigger than the slope. So at any rate, 0.1375. So question 10, restart the video once you've done question 10. So how many hours would it take for his blood alcohol content to drop below the legal driving limit of 0.08? You'll notice taking a cold shower doesn't help. So set up and solve an inequality to answer this question, please. So inequality. So first of all, we're going to start with the equation. So blood alcohol content, we want that to be 0.08. And we're going to have negative 0.015. We're going to calculate the blood alcohol content, the actual blood alcohol content, and we'll multiply that by x. And then we're going to add 0.16. And what we want is for the actual blood alcohol content, this part right here, to be less than 0.08. Okay. because we want it to drop below. And you'll notice I don't use less than or equal to. I want it to be less than, because if it's equal to, then you still get a DUI. So it has to be less than 0.01 or 0.08. Okay. So actual value is going to be less than 0.08, which means 0.08 is greater than that value. To solve the inequality, we then go ahead and work it just like we did our equation. If I have something subtracted, I add it back. Sorry. I got confused. If I have something added, I take it away. Minus 0.16. That 1/6 is in the way. I take it away from both sides. And you'll notice I'm going to end up with a negative 0.08. Now I have to divide by my negative 0.015, and hopefully you are realizing they're trying to see if you remember what happens when you divide by a negative. So cancels out over here. These cancel out. I'm just left with x. And negative divided by a negative is a positive. But if you want to do that on the calculator, 0.08, and I'll push the negative button to make it negative, divided by 0.015. Again, I push the negative button to make it negative, and I get a positive 5.33. But I'm actually going to flip the inequality around. And let's think about it in the context of the problem to see if that really makes sense. Okay. We've got 5.33 hours. At 5.33 hours, according to the calculator, our blood alcohol content will be 0.08, which is what we're looking for. Although we actually want it to be less than that. So do we need to wait less time for it to be less than that, or do we need to wait more time for it to be less than that? Actually, as time goes on, the blood alcohol content goes down. So it will actually take more than 5.33 hours to get our blood alcohol content below 0.08. So it does make sense in the context of the problem to turn that inequality sign around. Okay, and that's consistent with what we found when we did our inequality lesson. One more thing, though, important. How many hours will it take below the legal limit? I thought it said hours and minutes, but I don't see that. So that must have been a different problem. So how many hours will it take? It will take more than 5.33 hours, so at least 6 hours. Okay. Looks like we've got a did you get it? Set up and solve an inequality that will tell you what time John's blood alcohol concentration is more than half the legal limit. So, kind of interesting. That's an interesting one. I'm surprised they asked it that way because they wanted to be more than half the legal limit. Okay. So check your answer on that. If you don't get it, let me know. We can have some discussions about that. Question 11. Restart the video once you've done question 11. What information would you need in order to draw the graph of your equation? Be specific. Okay. Hopefully you realize by now that really all you need is the y-intercept and the slope. You could have also said you need 2 points. 2 points will do that. They give you 2 points. You can actually calculate the slope and y-intercept from 2 points, which we will do in later lessons. But at any rate, that's basically what you need, one or the other, 2 points or y-intercept and slope. But actually, you could have slope and any 1 point. It doesn't have to be the y-intercept. So anyway, go on to question 12. Looks like you need to draw a graph again. Once you have that done, come back and we will discuss it. All right. So blood alcohol content, hours after midnight. I want to see how many hours this is going to take. If I'm going to draw this, I need to know how many hours it's going to take. You may or may not have done this. It's okay. But I'm going to take my 0.16 divided by 0.015. Okay, so I'm going to have to go 10.6666 hours to get to 0. And it looks like I've got 1, 2, 3, 4, 5, 6, 7, 9, 10 lines. So I have to make a decision because that's pretty close. I could get pretty close to the x-intercept. I'm going to do that. I'm going to make each line 2 hours after midnight. So I won't actually get right to the y-intercept, or to the x-intercept, but I'll get close. Okay, and I know my highest point is going to be 0.16 because that's where we start, and we go down from there. It looks like I've got 10 lines there. So if I make each line 0.1, I will be way too low. So I'm going to make each line 0.2. I could. That's actually going to make the graph smaller than it needs to be, but it's going to be easy numbers to work with. So the first line is 0.2. Second line is 0.04. I'm sorry, the first line is 0.02. I forget whether I said the 0 or not. Fourth line is 0.08. And the sixth line is 0.12. The eighth line is 0.16. Then my last line is 0.2. We don't necessarily need to put that on though. And my origin is 0. It's 0 hours and it's 0 blood alcohol content. But at 0 hours, the blood alcohol content is 0.16. So I put a dot there. We haven't really done a table yet, but we've got something that's pretty close. we go back here, we know at 5 hours we're a little bit more than 0.8. So I'm going to take that. I'm going to go negative 0.015 times 5. So I'll say 5 hours plus 0.16. 0.015. Okay. 0.015 negative times 5 hours plus 0.16. I get 0.085. So at 8 hours, I'm a little bit more than 8. Actually, about a quarter of the way between 0.08 and 0.10. So that's going to be my 5 hours. Oops. I'll put it under 8 hours, but that's going to be my 5 hours. And I know at 10 hours, I'm a little bit more than 0. So I can draw that line in. Okay. You're actually doing a graph. If you use a ruler, you really only need 2 points. What is the x-intercept? What does it mean? Answer that question and then restart the video. If you think back, when I did this division, I got 10.33333, I believe. 10.66666666. And when I rounded off, I put a 7 at the end. So that is actually my x-intercept. What does it mean? At 10.67 hours, the blood alcohol content is at 0. So the person is completely sober. Quick discussion here. Read through this, and then I'll talk about what we're going to say. So restart the video once you've read this. So connection between slope and direction. Okay. So when slope of the line is positive, it means it goes up to the right. It goes down if you're going to the left. Slope is negative, it means you're losing, which means the line is going down to the right. As time increases, the alcohol content goes down. So negative slope, you're losing something. Positive slope, you're gaining something. Okay. So question 14, sketch a line with a positive slope. Sketch a line with a negative slope. Can you describe what a line with a slope of 0 would look like? That's going to be a little more challenging. So sketch an example and label this line on the graph below. So restart the video once you've done those 3 things. All right, so 14, sketch a line with a positive slope. Okay. Doesn't really matter where you start or how fast the line goes up. I could have drawn a line like that. As long as the line goes up when you're going to the right, when you go to the right, the x gets larger. If x is getting larger and y is getting larger, you have a positive slope. Question 15, that's a negative slope. As x gets larger, y gets smaller. So actually you should label these what it says Okay. What would a line of zero slope be? So positive slope as x goes up, y goes up. Negative slope as x goes up, y goes down. You have a zero slope as x goes up, y does not change. So a zero slope is actually a horizontal line. And I think that is the end of the lesson. So remember, no technology, but we do have online practice. That is the ALEKS program. You need to do your ALEKS. And don't forget to do the looking ahead. I think I've been forgetting to mention that, but it basically just says do the prep skills and read the opening paragraph, which hopefully you're used to doing by now. The answers to the problems, and then do the applications. And as always, you can do the applications in your book, take a picture of the pages, and I will have a place for you to upload them to D2L. Remember, let me know if you have any questions. We can have a WebEx session. If that will help you, be happy to do that. But as long as nobody asks for that, I will assume that you don't need it. So anyway, take care of yourselves, and I will see you in the video for lesson 8.